Section 7.5 is the final section of Chapter 7, Solving Rational Equations. We start with a vocabulary term, and it's more of a statement rather than a vocabulary term, cross-multiplying. It's a method we're going to use to solve rational equations. What cross-multiplying says is that if A over B is equal to C over D, and we can see A over B, C over D, then what we can say is that AD is equal to BC. This is kind of the general rule of proportions, how you can tell if two fractions form a proportion. You can take the cross products, and if they're equal, then they are a proportion. So, solve by cross multiplying. Check your solution. So here's what we're going to do. We're going to take the upper left times the lower right. So it's going to be, I'm going to get rid of that. We're going to take 3 times x minus 7, and then we're going to take the make this equals. We're going to take the lower left, multiply it with the upper right, so it'll be 5x times 2, and then we're going to go from there. We're going to solve it. So we're going to have 3 times x minus 7 gives us 3x minus 21. That's an x. That's equal to 5x times 2 is 10x. Now, this is just a linear equation. This shouldn't take us too terribly long to solve. We just need to move the x's to the one side. You're going to do that by subtracting 3x from both sides. So negative 21 is equal to 7x, which then we can imply that, or infer that x is equal to negative 3. Now it does say check your solution, so let's just go back and double check. So we're going to have 3 over 5 times negative 3 equals 2 over negative 3 minus 7. 5 times negative 3 is negative 15. Negative 3 minus 7 is negative 10, so 2 up there. And then we just need to simplify these fractions. 3 over negative 15 simplifies down into negative 1/5. 2 over negative 10 is also negative 1/5. So we do, in fact, have a solution. Your x is negative 3. That's your only answer. Number 2, negative 4 over x plus 3 equals 5 over x minus 3. Again, we're going to just cross multiply here. So I'm just going to do this all in one color. So we're going to have negative 4 times x minus 3, and that's going to be equal to 5 times x plus 3, cross multiply, distribute here, so we'll have negative 4x plus 12 is equal to 5x plus 15. Again, we need to move the x's to one side, numbers to the other, since it is a linear equation here. I'm going to put the variables on the right-hand side. I'm going to add 4x to both sides. So that gives me 9x. I'm going to put the numbers on the left-hand side. That means I need to subtract 15. So that is negative 3. So then we can say that x is equal to negative 1/3. When we go back and check here, we'll have negative 4 over, negative 1/3 plus 3. We're going to see if that's equal to 5 over negative 1/3 minus 3. Negative 1/3 plus 3. So we're going to have negative 4 over, that's going to be a positive 8/3. So I'm just going to go 8/3. And negative 1/3 minus 3 is actually going to be negative 10/3. Okay, if you don't trust me, you can definitely turn that into thirds. Both of these can turn into thirds and then just combine your fractions. I'm just skipping that step. From here, you can use your calculator. Just make sure your 8/3 and negative 10/3 are in parentheses. What you're going to find is that the left side is equal to negative 1.5. The right-hand side is also equal to negative 1.5. So that does match up. So then negative 1/3 is our solution for example number 2. Whoops. Get rid of that line there. Number 3. 1 over 2x plus 5 is equal to x over 11x plus 8. So, once again, I'm going to cross multiply here. 1 times 11x plus 8 is just going to be 11x plus 8. I'm not going to write the 1 because I'm just multiplying by 1 here. The other cross product, 2x plus 5 times x, I'm just going to write that out as well. 2x times x is 2x squared. 5 times x is 5x. So now we can go from here. Now, we have an x squared, which means we needed this equation to be equal to 0. So I'm going to move the 11x over. I'm going to move the 8 over, minus 11x minus 8. So I've got 0 is equal to 2x squared minus 6x minus 8. This works out really well because 2, 6, and 8 are coefficients. 2, 6, and 8 are all divisible by 2, which means we can get rid of the 2's. So we'll have x squared minus 3x minus 4. This becomes much easier to factor this way. We need two numbers that multiply together to get negative 4 and add together to get negative 3. Those two numbers are going to be negative 4 and positive 1. So then when we solve this, we come up with solutions of 4 and negative 1. Now we need to check both of them actually. So I'm going to check the first one in green. So we're going to have 1 over 2 times my x value of 4 plus 5. We're going to see if that's equal to 4 over 11 times 4 plus 8. Okay, that's an equal sign. 2 times 4 is 8 plus 5 is 13. So we're going to have 1 over 13 is equal to, let's see, 4 over 11 times 4 is 44. 44 plus 8 is 52. And 1 over 13 is simplified, but 4 over 52 is not. That is also 1 over 13, so that one checks out. So x equals 4 is a solution. Now we need to check the other one. I'll do the other one in red. Okay, same thing, plug in your x value for all the x's in your original equation. 1 over 2 times negative 1 plus 5 is equal to negative 1 over 11 times negative 1 plus 8. Let's see, 2 times negative 1 is negative 2, plus 5 is 3, so I'm going to have 1/3 on the left. 11 times negative 1 is negative 11, plus 8 is negative 3, so we got negative 1 over negative 3. Those are, in fact, equal. If you got two negatives, they cancel each other out. This works as well. So you do have two solutions here. You have 4 and you have negative 1. If you have an equation that isn't set up nicely like a proportion like you see here in the example on this page, one way we can solve this is by using the least common denominator, or the least common multiple. So the steps here, we're going to find the least common denominator of all of the parts. Okay, hopefully when you do this, at least one of them, at least two of them will match, like these two do down here, or we can make them match. And I got an example after this one that shows that. Once we find the least common denominator, we're going to multiply everything, each of these terms, by the least common denominator, and then we're going to solve the resulting equation. I'm going to show you what this looks like here in just 1 second. So let's just jump right into this. So we've got 5 over x plus 7 over 4 equals negative 9 over x. First thing we need to do is find the LCD. So find the least common denominator. Let's see, we only have two denominators here. We have x and 4. Well, I should say we have two unique denominators here. So let me go back to the pen. X is equal to, well, that's just x. 4, we could break this down into 2 times 2, but there's nothing that they're going to share, so we can make this 2 times 2. So then the least common denominator is going to be 4x. Okay, so what we need to do with that 4x is we need to multiply each of these three terms by this least common denominator. And something really nice is going to happen when we do this. Okay, so I'll do the first one in green. So we're going to take 5 over x, and we're going to multiply that by, I'm going to make this 4x over 1, just make it a fraction so it's really easy. The x's happen to cancel out here, so really what we're left with is just 5 over 4 times 1 over 1, which is 20. Okay, we'll do the next one in blue. We're going to have 7 over 4 times 4x over 1 again. Okay, this time not the x's cancel, but the 4's do. Okay, so we have 7x over 1, or just 7x. And then I'll do the third one, the other side of the equal sign in red here. So we're going to have negative 9 over x times our common denominator of 4x over 1. Once again, the x's cancel out, and we're left with, let's see, negative 9 times 4 is negative 36, and then 1's in the denominator, so we got negative 36. So what we've got then is we've eliminated all of the fractions. None of these three terms now are fractions. We've got 20, we've got 7x, and we have 36, well, negative 36. So what we can do then, just replace all of these original terms here, here, and here with our new terms after we multiplied by the least common denominator. So it's going to be 20 plus 7x is equal to negative 36. Now that is something that is very easy to solve. It's a linear equation. It's algebra 1. It's pre-algebra stuff. Okay, so we're going to move the 20x over, so 7x is equal to negative 56, and then when we divide by 7, we find that x is equal to negative 8. Now we should go back and double check that all of these, that this answer works. Let me switch to a different color. We'll go to orange this time. So we're going to have 5 over negative 8 plus 7 over 4 is equal to negative 9 over 8. Now, 5 over negative 8 is negative 0.625 as a decimal. 7 over 4 is 1.75, and negative 9 over 8 is negative 1.125. And when you do these two, when you add these two together, you do in fact get negative 1.125 is equal to negative 1.125. So in fact, negative 8 does work out. Let me get rid of the check mark. Negative 8 is our solution for this example. Sorry about that. Let's try another one here. 1 minus 8 over x minus 5 is equal to 3 over x. Now, once again, we need to find the least common denominator. What I'm going to do, though, is I'm going to rewrite this first term, 1. To me, it makes sense to rewrite this as x, whoops, let me go back to the pen, x over x minus 8 over x minus 5 is equal to 3 over x. Now, you could, I guess, write it as x minus 5 over x minus 5, because it still would, in fact, be 1. But to me, x over x just seems a little simpler. Whether or not that's the case kind of remains to be seen. But to me, I'm going to go with x over x. Okay, so we need to find the least common denominator. Okay, so we have two unique denominators now. We have x and we have x minus 5. So x, well, that's just equal to x. And x minus 5 can't be broken down either. So that's just x minus 5. That's an x, by the way. X minus 5. So then the least common denominator is going to be x times x minus 5. There's really not much we can do with this other than write them together. Okay, so the first term I'm going to do in green again. So we're going to have x over x times, I'm going to go x times x minus 5 all over 1. Okay, so then the x and x cancel here. So I'm left with x times x minus 5. And I'm actually going to write this out. That's going to be x squared minus 5x. Okay, do the second term in blue. So we're going to have negative, actually we'll just forget the negative sign for now. We know that it's going to be minus here when we substitute everything in. So we're going to have 8 over x minus 5 is, then we're going to take that times our common denominator, x times x minus 5, all of that over 1. So the x minus 5s cancel out. And on the top, we're left with 8x. On the bottom, we're left with 1, so it's just going to be 8x. Now, when I substitute this back in, that'll have to be minus 8x. Just make sure you don't forget that part. And then the third term, we've got 3 over x, and then times our common denominator again, x times x minus 5, all of that over 1. And let's see, the x's cancel out again, so we're left with 3 times x minus 5 is 3x minus 15, and again, that's over 1. So we can actually rewrite our equation here. We're going to have x squared minus 5x minus our middle term, which was 8x, and that's equal to 3x minus 15. Now we've got a quadratic equation. We want to get everything to one side, okay? So let's move the 3x minus 3x minus 3x. We'll add the 15 as well. So these will all go away. This is equal to 0. Going to have x squared. So we're going to have negative 5x minus 8x is negative 13x. And then negative 13 minus 3x is negative 16x. So minus 16x and then plus 15 on the end. Let me slide this up a little farther. I'm out of room, so this is as far up as I'm going to be able to move it. So we can still solve this. This is factorable. Make this equal to 0. We need two numbers that multiply together to get 15 and add together to get negative 16. Those two numbers are negative 15 and negative 1, which then we can say our solutions are positive 15 and positive 1. Now we do need to go back and just double check that. I'll do the first one in green. So we're going to have, let's see, we should probably use the original problem. So we're going to go 1 over 1, which is just, well, actually not 1 over 1, x over x, which is just 1. So we're going to go 1 minus, and let me go back and make sure I have this, 8 over x minus 5. So 8 over, and our x is 15. So 15 minus 5 is equal to 3 over x. So 3 over 15. Now, we'll have 1 minus, 15 minus 5 is 10, so we'll have 8 tenths. That simplifies down into 4 fifths. And 3/15 simplifies down into 1/5. And hopefully you can see that 1 minus 4 fifths, we'd have to rewrite this as 5 fifths minus 4 fifths is equal to 1/5. That is in fact true. So our solution of 15 works. Now we need to go back and check the other solution. I'll do that one in orange, okay? We're going to have 1 minus 8 over, let's see, this is an x, so it's going to be 1 minus 5. And then that's equal to 3 over x. Our x is 1. Now, let's see, 1 minus 5 is negative 4, so we're going to have 8 over negative 4. 3 over 1 is 3. 8 over negative 4 is negative 2, so this is going to be 1 minus negative 2 equal to 3. That does, in fact, work as well. 1 minus negative 2 is 3. So we do have two solutions here for this example, 15 and 1. The last section the last topic in section 7.5 is finding inverses of rational functions. And when we find inverses, the rules are exactly the same as section 5.6. If you go back and take a look in your notes, 5.6 was just inverse of a function. The rules, remember, switch x and y and then resolve for y. So these shouldn't be too terribly difficult. Number one, find the inverse of the function. Whoops, let me get rid of that. It's supposed to be sliding up. F of x is equal to 2 over x plus 3. Once again, remember that we need to replace f of x with y first. So y equals 2 over x plus 3. And then once we do that, we need to switch x and y. So now it's going to be x is equal to 2 over y plus 3. Now we need to resolve for y. Ideally, we want to get the y out of the denominator as soon as possible. Okay, so we're going to do that by multiplying both sides by y plus 3. Okay, y plus 3 gets multiplied on both sides. So we're going to have, I'm going to leave it as x times y plus 3 is equal to, now the y plus 3's will cancel on the right, and on the left, or on what remains on the right, is just the value of 2. And then we need to go about solving for y. We want to get y by itself. What we're going to do next is we're going to divide both sides by x. Okay, those will cancel on the left. So then we're left with, on the left-hand side, just y plus 3, and then 2 over x on the right-hand side. And then we just have one more step to get y by itself. That would be to subtract 3 from both sides. Okay, so we're left with y is equal to 2 over x, and then minus 3. This would be your answer for example number 1. Sorry about the bell there in the background. Number 2, f of x is equal to 1 over x minus 2. Once again, switch x and y. I'm going to jump this first step where I replace f of x with y. I'm going to go ahead right to this next step. So it's going to be x, whoops, I'm going to go back to the pen, x equals 1 over y minus 2. Like I said, I just skip this step where I bring in y for f of x, and I jump right to switching x and y. Okay, now we just need to resolve for y. Excuse me, what the first thing I'm going to do here is add 2 to both sides. Okay, because the y, or the minus 2 is not directly attached to y, so we're going to get rid of that first. So we've got x plus 2 is equal to 1 over y. The next thing we need to do is we need to multiply both sides by y. Okay, we're going to take y times both sides. So we're going to have y times x plus 2 is equal to, the y's cancel here, we're just left with 1. Last thing we need to do is we need to get y by itself. We're going to do that by dividing both sides by x plus 2. Divide both sides by x plus 2. Those will cancel out. We're left with y equals 1 over x plus 2. And that would be the inverse of your function for problem number 2.